For everyone who's joining online, could someone confirm if I'm audible?
Yeah.
Okay, great. So one of the pre-processing steps that we wanted to do was look at all the fields and see if there's any unwanted feature that the data has. So for example, if you look at all the URLs, you can see that there's this extra new line character at the end of all the fields. So we want to get rid of that. And so this is a simple one-liner function. And from what we saw last time, Lambda functions are great for this sort of data processing. So we can just apply a Lambda function that says replace all new lines with blank strings. And then we reset the value of the URL column from tag main to this newly processed value. So if we take a look at just this guy here. So this basically returns a pandas series with the process data, and then we're reassigning this to the URL column of our main data frame. So if you look at the 0th row of this data frame, you can see that the new line at the end is no longer there. So similarly, for the name column, we want to apply some sort of pre-processing. So let's look at how the name column looks like right now. So it's basically the speaker's name, a colon, and then the actual title of the talk. So what if we want to apply a function, but we want to use two different columns of the data frame? So if we apply a Lambda function directly, like we did for URL, you basically just use the column name and then call a dot apply on it. But what if you want to use more than one column? So in that case, you can call a dot apply on the main data frame directly with your custom function name, and where you specify axis equals 1 for indicating that you want to apply it to every single row instead of just to applies it on one column. So in this case, our function is taking the whole row as an input, and then it's using the name and the main speaker column to get rid of the main speaker from the name. So if you look at the name column right now, it's speaker appended by the title. Once you apply this function, after that, it's going to be just the title without the name because we got rid of it. Any questions about this? The axis equals 1 part? Yeah. So in the first, so the question was, what does axis equals 1 do? So in the first part, what we did was, we know that there's only one column that we want to pre-process and get rid of the new line at the end. But in the second case, we want to use two different columns of the data frame and apply a function to that. So in that case, what we do is we call the dot apply on the entire data frame. And so the function that we're calling using dot apply will take the entire row as input. And so by default, this function uses axis equal to 0, which means that it applies the function to columns, just individual columns. When you specify axis equals 1, it applies it to rows.
So what your function gets when axis equals 1 is a dictionary, essentially. It's a pandas series, but it kind of works as a dictionary. So that's the entire row. You can access any variable using the key.
So in addition to our main tag main data set, we also have a transcripts data set. So if we take a look at what that looks like, let's just see an example transcript from here. So it's basically the text of the entire TED Talk. And you can see there are some weird things in here as well. For example, you have this laughter enclosed in brackets, which is clearly not a part of the original talk itself. It's something that's been added in later. So we want to get rid of things in this text that are enclosed in brackets. So the way to do that is the easiest way is using regular expressions. So you can find many tutorials online on how to create regular expressions of your own. But basically what this one is doing here is it's looking for an open bracket and a closed bracket between which you have at least one character repeated once or more. I don't know if that makes sense. Any questions about that? So this is basically we're escaping the open bracket, followed by the bracket inside is just indicating the dot means a single character. the star means repeated 0 or more times, and question mark means repeated 1 or more times, right?
Yeah.
So when we apply this replacement function to transcript, we're basically getting rid of everything that is enclosed within brackets. So now you can see the stuff that was inside parentheses, like laughter, has been gotten rid of. Okay, so moving on, one other thing that you need to do before you start doing any machine learning on your data set is to visualize all the distributions of your input and output columns. So Pandas has an inbuilt function that lets you call a histogram on all the columns in your data frame, the numeric ones. That basically gives you a histogram of every single numeric column in your data set. But as you can see, this looks a bit messy. So you can use matplotlib to improve your plots and just help things cleaner. So this function here, plt.tight_layout, is basically a cleanup sort of function, which just makes your plots look better. In case you're not interested in all of the columns and you just want to look at one in particular, you could also call it on one single column. So for example,
There's a string array.
oh, it's number of comments. So in case you're not happy with the granularity of the number of bars in this, you can also specify this as an argument where you say bins equals the number of buckets that you want.
Everyone understands what a histogram is, right? Anyone who wants some clarification? So the y-axis here is the count of the rows that have the value at x.
Can you please explain more on bins? What do the bins do?
Sorry, we can't hear you. Can you type your question?
Okay, can you try asking the okay, more on the bins.
Oh, okay. So there are two questions. One is, can you explain more on the bins? So basically, bins is the number of buckets that we're splitting our data into. So for example, here, what we can see is, let's just set this to 10 bins. And so what this is telling us is, if we make 10 equal buckets of the data after we sort it based on our x-axis, which is the number of comments here. So our first bin is something from 0 to maybe it looks like 500. So this is telling us that there are 2,500 rows which have the number of comments between 0 and 500. But if that's too big of a bucket for us, we can specify this to whatever value we want. So this makes it a little bit more granular, and now it's roughly 0 to 200, and then there's a little more than 2,000 values at within this bin. And the second question is, what function can we use to display it like a bell curve? So that actually depends on the data. And in this case, the comments data is not in the shape of a normal distribution. It's not a bell curve naturally. But usually what happens is, if you plot the distribution of the log instead of the raw data directly, most of the times it ends up looking like a bell curve. So let's see what that looks like. So we have some invalid values in our TED main comments. So syntax for this is going to be a little bit different. We're going to use plt.hist instead of using the inbuilt pandas hist, because we have some invalid values in our panda series. Log on it. So most of the times, the data does end up looking like a bell curve if you plot the log instead of the raw data. And in this case, you can increase the bins as well. So what the PLT, the matplotlib histogram function returns is a list of the number. The first array is the list of the number of observations in each bucket. And the second one is the start and end points of each bucket. Any other questions about histograms? Okay. So
Can you plot
so the function that we just used was plt.hist, which was for histograms. Plt.plot is for regular graphs, which like regular pointwise graphs, each with one x and one y coordinate. So the first parameter here is the x values, the second one is the y values. So in here we're
speakers. I heard in the airports.
Okay. So maybe you can turn the speaker on.
oh, turn it on.
So do you hear the? Can you hear the question? Maybe you
No,
can
I
repeat it.
didn't hear the question. If somebody was saying something and then just started saying he stopped.
Oh, okay.
Maybe you can turn the mic on here as well. Maybe it's muted.
Sure. Okay. So what we're specifying as the x-axis here is simply an array of 4 numbers, 1, 2, 3, 4. And the y argument here is the number squared, which is what we're doing using a list comprehension here. And the dash O is specifying the kind of line with which we want to plot it. So if we simply set this to just dash, it's going to be a different kind of plot. The blue line that you can see here, that's simply the dash. I think if you set it to just dot, it's a different argument as well. So it just plots dots instead of connecting them with a line. We've just plotted 2 here for, as an example, but basically you can play around with these parameters and see what gives you what kind of plot. So these are some things you'll need to use when you plot for your data science project reports or any plots in general. You need to label your x and y axes, provide a legend for your graph, and you can also specify a title using plt.title. And there are also some advanced parameters that let you play around with whether you want which position you want the title and the legend in, and also the font sizes for your axes and axis labels. So also some advanced facilities, you can decide where you want your x-axis ticks and labels to be, same for y-axis. You can also set a grid for, if you want it just for the y-axis, you can see these extra lines have been added for every tick that you have on y. So if you set your y ticks and plt.grid on the y-axis, you'll get a horizontal line at every label that you have on your axis. So this is another handy function that tells us the correlation between every pair of columns in our data frame. So in this case, I think by default, it gives us the Pearson correlation coefficient. I don't know if you guys have covered it in class yet. So it gives Pearson by default. We can also set a parameter to make it Spearman. So we have these three most commonly used correlation types. You can just specify it as your method parameter. But the thing with correlation is it's usually difficult to just interpret the values directly from when it gets printed. So one handy library for visualizing tables like this is Seaborn, where you can simply say sns.heatmap, and then you give your data frame as input, where it maps every number to a color on this default color scale, and it prints it as a grid of colors. But this is also not as informative. So with some extra parameters, so in this case, you're specifying that your values are going to be from -1 to 1. You want to use this particular red-blue color map. You want there to be a gap of 0.2 between different cells. And this is setting, this is basically printing values in each cell. So there's another parameter that you can specify. I think it lets you format the numbers up to the number of decimal points that you want printed. Okay, so let's see what some of the other columns look like.
Does everybody understand what that plot was showing with all the variables? Okay, that's good.
Yeah.
There's a question. Can you explain what the heat map is from?
Let's count.
Maybe you can talk to it in the mic.
Oh, there's a question asking what is camp argument? Oh, I think you're talking about CMAP. So this basically specifies the color map that you want to use. So there's a big variety of default color maps that are available. Usually when we're plotting correlations, we go for red, blue, or red, green because we want to see negative versus positive very clearly. But if you have only positive or only negative values, you can also set it for white to another extreme color, or you can specify whichever color palette you want. You can play around with it. Any other questions?
And can you just go over what the heat map was showing again?
Oh, okay. So when you call a data frame dot correlation, the CORR function, it basically gives you a table of pairwise correlation. So if you look at each of these values, this is basically telling you that the Pearson correlation coefficient between the duration in seconds and the number of comments is 0.13. So that means there's a slightly positive correlation. The higher the duration, the more likely it is to get comments, more comments.
Right, and to break it down further, it means, if the correlation is positive, it means as one variable goes up, the other one goes up as well. And if it's negative, it's the relationship is opposite. So when one goes up, the other goes down. And the range is from -1 to +1. And if it's 0, then there's no relationship at all. Then it's a flat line.
There's another question. In order to visualize the distribution of a column, if I plot a curve of its logarithmic value, am I changing the meaning of its distribution, or would it be the right way to do so? So usually when you're plotting things, if you see that if you plot the log distribution and it turns out that it's a bell curve, then that's a step that you can take in preprocessing, where instead of using the raw column as input, you can use the log column as input. Then that won't affect or that won't have a negative impact on your model in any way.
Right, and the sort of a key word here is monotonic. So log is a monotonic function. It doesn't affect the range of the values. I hope that answers the question. So it sort of retains the order and of the original variable. If you apply log, in most cases, to summarize, log should be fairly safe. You just have to be transparent and communicate that you're using the log of the variable. And to answer the next question, it's just a function of how Pearson defines the correlation value. So we didn't normalize it ourselves. It's just it's hard coded in the formula using a denominator, which ensures that the value ranges from -1 to 1.
There's one more question.
If you have a string column, then it is not resulting in a solution, right?
Right. So the question is, if there's a string column, does it have a value in the correlation table? So no, it just takes numeric values from the table and computes between all pairs of numeric values.
That means you have to have a one-shot encoding for those.
Right. We're going to get to that. So I think we're getting an error here because we didn't do a drop any in place. Let's try doing that. Might also be because we're trying to compute a log of 0 that's resulting in minus infinity. So the solution to this kind of problem would usually be to drop the ones that have 0 or replace it with a very small value. Or if you just want to look at the data without changing the contents of the data frame, you can use plt.hist instead of doing that. So for the duration as well, the original data somewhat looks like a bell curve, but once you take the log of it, it resembles a bell curve more, although it is biased towards one side more than the other. So this is something you need to do on a regular basis, where you look at the distributions of all your input columns and then see whether you need to perform some sort of an operation on it, like either log or squared or any other pre-processing before you use it as an input column. So even for views, this is the difference is very pronounced. So let's move on to the next part, which is actually using all of these columns for doing a prediction task. So if we look at the speaker's occupation and we look at the value counts function, this basically tells us the distribution of every, the counts of every unique value in this column. So this is telling us that there are 45 speakers with the profession writer, 34 with designer, and so on. But because we have 1458 of these, we don't want to predict every single column here. Instead, we just want to limit it to, let's say, the top 50 ones. So the way that we're doing this is we're converting this value counts into a list. That's, let's see how the list looks like. So when you look at just the top 50 ones, it gives you a series of index to value. And then when you call dot index on it, it just returns the speaker occupations.
Note how value counts is kind of like histogram, but not really, because it's a string variable, but it kind of is essentially accomplishes the same thing, where it tells you what values the column takes on and what's the frequency, what's the number of rows that have that value. So if you wanted to plot it kind of like a histogram, you would do it using a bar plot. So you call value counts and you pass that on to the plt.bar.
Maybe we can cover that in the end if we have time.
Yeah.
So in speaker occupation, basically what we're doing is we're checking if it's in the top 50 most common professions. Otherwise, we're just setting it to others. So we're just modifying this speaker occupation column in place and setting everything else apart from top 50 to other. So now if you look at this, we have a majority of the rows in our data frame set with speaker profession as other, and the remaining ones are set with whatever value was there in the top 50.
Any questions?
So like, instead of doing this, can we not group different professions? Like, let's say if somebody is related to climate, probably we can group 4 or 5 professions together and could be a better, what do you say? Like, because here other is 1848, which is almost.
Right, that's a good point. Depends on what you're trying to accomplish, but that could definitely be done. Sorry? Sorry, to repeat the question is, would it make sense here to group together similar professions? So, if it's a writer, artist, maybe clump them together as a creative profession, And that makes sense. And you, in some, in your assignments and projects, you might need to do something like that. Yeah, it depends on what you're trying to accomplish and what's the goal here.
So in that case, I think it would require some sort of manual preprocessing where you change this lambda function and then write your own if else over there to group it in whatever way you want. So the thing with this is, if you look at the data frame in its entirety, it's just going to be a list of speaker professions, but you can't use this directly as a feature. So what we do for that is one-hot encoding, which means you convert every string feature or every non-numeric feature into this row of numeric values that you can use. So basically what this does is, if, for example, if for this row, this says climate advocate, then the value for climate advocate will be 1 for that row, and everything else will be set to 0. So Pandas has this inbuilt function that does this automatically for you. So this is converting it into a data frame of 51 columns, where each column is corresponding to one speaker occupation. And for whichever row had that set as its value, the value in here is 1 and everything else is 0. So we're basically converting non-numeric features into numeric features that we can use for prediction. Any questions about this?
For those joining remotely, you can also say your questions on your mic. We've tried to fix the speaker issue here. So this is what you were alluding to, right? How to encode string variables as numerical variables so that you can use machine learning or any other analysis on them. Does everybody understand what classification is? Because that's what we're building towards, right? It's just trying to predict a variable, specifically a categorical variable from the other features. I'm not sure if Steve has covered classification yet in the course, but just to give you a broad overview. So we're going to try to predict the profession, I think.
I think we're predicting the tag, and we're going to see if technology is one of the tags or not.
Right.
That's
so we're going to, So we're going to try and predict if the talk was related to the subject of technology using the other columns. In this case, it's binary. It's going to be the true or false.
So this is the standard Python library kind of way that you would do this. So from sklearn.model selection, this is a common function that we use. So our input columns are going to be the one-hot vectors that we just got, the 51 column matrix, which was encoded, one-hot encoded speaker professions. And why the value that we're trying to predict is going to be whether or not technology is one of the tags for that, that talk. So when you run this, let's also look at the what the data looks like. So with train test split, what we're basically doing is telling it that we want 30% of the data to be in our test set and the remaining 70%. If you look at the lengths, they're corresponding to that ratio as well. And if you look at the original value counts from our to predict column, so we had this distribution where 723 of our talks do have the technology tag and the remaining ones don't. And then let's also look at the distribution within our train and test sets. So the distribution again is roughly similar between all three. So when you use sklearn.train-test-split, you don't need to worry about whether the distribution across train and test is changing by a lot. So what we're going to do is we're going to train a model using X-train and Y-train, and then use the model to predict on the unseen rows in X-test and see how well they map to Y-test. So this is also an out-of-the-box sklearn library object. You can just specify your classifier as a logistic regression, and you want to fit this model on your X and Y training data. So these two are the first steps where you use the data that you have, and then this is the step where you try to see how it performs on unseen data. So this function here as well is this inbuilt function that tells you how accurate your test predictions are. So in this case, we're doing it 76.05%, which is not bad. If you want a more detailed report, you can also use this classification report, where this gives you precision recall and F1 score, and support, which is basically telling you how many values from the test set that was this predicted on. Any questions about this?
For those new to machine learning, this might be a little overwhelming, so feel free to ask questions.
So just to reiterate, the input data that we're using is the one hot encoded matrix of speaker profession, and the Y column that we're trying to predict is whether or not the talk is related to technology.
And so we've split the data into like 75% rows for training, for learning the task, and we're going to use the 25% to actually get the score. Yeah.
Training test split random?
So the general rule of thumb is that the split should be something like 75, 25, 60, 40. But you want to have, like, correct me if I'm wrong, you would ideally want to use more data for training than testing. Yeah, that has.
Yeah, this is based on this random seed parameter for this function.
So that's very important. Yeah, that's a good point. It has to be random because you don't want to be testing on a biased set of the entire data set.
And this is also something else that we'll cover if we have time. So usually what we do is it's not enough to just train it on one split. So we split it with using different random seeds, and then we take the average accuracy or precision or whichever metric we want over the multiple splits.
And that's called cross-validation. So there's a question in the chat saying, what is support macro average, weighted average? I guess they're talking about the classification report, the columns. Yeah.
So support is going to be the number of rows in the test set, if I'm not wrong, that it predicted on.
Yeah.
Was that equal to the values? Yep. So if you look at Y test, you can see that the number of values for true and false in here are the same as what you see in support. So this is useful when you have a highly imbalanced data set. For example, if you see like there are 500 values in here and just 10 in here, then the numbers over here are probably not as reliable.
Does that answer the question? And the other question is, can you perform k-fold cross-validation with train test split?
I think there's an inbuilt function for k-fold cross-validation as well. There's an sklearn library, I believe, called.
Right. And so if you want to use train test split, there might be a parameter. I think not. This is again where it's useful to read the documentation of these functions, because you're not expected to sort of memorize what these functions take on as variables. But if you must use this function, you would do something like use it in a loop or something. Yeah, that's what I imagine it might look like. And like Charuta said, there's a dedicated function for cross-validation that comes in scikit-learn, which is the library we're using.
So that would perform all of your train test splits for you, and based on the number of splits that you specify, and give you those aggregated results automatically. There was also a question about macro average and weighted average.
Yeah.
So if you look at the documentation here, it specifies what micro and all these other printed values are. So you can take a look at these for the detailed definitions. So the one that we saw right now is the out-of-the-box logistic regression classifier. Another one, so Python has all of these inbuilt library modules that you can use for as classifiers and regression as well. So instead of logistic regression, if we try using the decision tree classifier, the method is pretty much the same. You use the off-the-shelf object, you fit it on your training data, predict it on your test data, and then look at the accuracy. So in this case, this is performing slightly worse than the logistic regression one.
So there's a question here.
So what was the solver argument or parameter?
That solver parameter we specified in the initialization of the logistic regression classifier?
I think this was a Python versioning issue. Oh, it's not there anymore. So logistic regression lets you specify which algorithm you want to use for fitting to the training data.
So I think Steve would go deep into like these different like training algorithms and how it learns the boundaries.
We can look at the possible values for that parameter as well in the docs. So it basically, it's based on which loss you want to use for fitting on the training data. You'll go into that in more detail later.
So there's a question saying, can you show the one hot vectors again to see how it relates to the technology tag?
So the one hot encoded vectors are just vectorized forms of the speaker occupation. So that's just the X data. It doesn't have any relation to the Y data yet.
So yeah, that's an important point as well, where you don't want any mixing between your features and the variable you're trying to predict, which is the Y variable, the technology tag here. So ideally, they would be, dare I say, independent. Ideally, you would want some level of independence between the features and the variable that you're trying to predict.
So I think what they mean to say is, like, for example, if you have engineer set to 1, does that translate into technology more as compared to comedian? So I think we'll cover that when we go to feature importance in the next notebook.
So yeah, so when you train a classifier, what it does is it essentially weights the features that you give it, and you can have a look at how it weighted those variables to identify which feature is most relevant to the task at hand. And we'll, I think, cover that in the rest of the lecture. Any other questions? Yeah.
Yeah, so I guess there's a concept called label encoding where you give, let's say, engineer 1, climate advocate 2, instead of putting 1 zeros, right? So when should we use one hot encoding and when should we use label encoding?
So I think so the question is, there's this concept called label encoding where you assign numeric values to all of your string values. For example, children would be 1, creativity would be 2. So the difference between the two is one hot encoding is generally done on input features, because you have strings in here that you want to vectorize in some sense. And when you're doing label prediction, so the only time you would want to convert your strings to numeric values would be if there is some sort of the strings translate to numeric values in some sense. So like mild would be 1, strong would be 5, something similar to that. And then you do a regression on those values instead of classification.
So just to clarify, for classification problems, we should go for one hot encoding, not for label encoding, something like that.
So I think you might want to go for label encoding if you're doing something related to multi-class classification. Otherwise, you would just stick to one hot encoding your features or some other way to featureize your strings.
Yeah, hot one encoding is, I would say, the simplest way to encode string variables. So it's a good place to start always. But yeah, you should explore more ways to encode the features, whichever gets you the best results. Any other questions?
What does index in the axis denote? Like in some of the parameters that were used.
I'm sorry, the question is, what does the index denote?
Yep, and the axis as well denotes, yeah, in those parameters.
Can you specify like where?
Like in this, you could see axis equals to 1, right?
Right.
And in some of the cases, I used to see like index equals to any. So I wanted to understand like what these two features are.
So when we specify axis equals 1, that means you want to perform the operation on each row. And when it's axis equals 0, it means you're performing it on each column. Index, I'm not sure which one you're referring to.
Does that answer your question about the axis?
Yep. For axis it's clear, but now I wanted to understand about the index.
Can you like give us the cell code number, the cell number?
Like you can just like search index equals to any.
Any.
No, that's not there. I think what you're referring to is when we did drop any and we specified how equals any, was that?
Yep. You're right. Yeah.
Oh, okay, so when we call this drop any function, what any is telling it is basically if any of the columns in that row are set to none or null, we want to drop that row entirely. So instead of that, if we set this to all, this would mean that drop it only if all the values in that row are none.
Or you can
Okay.
specify the specific columns that you're interested in. Yeah. Does
Okay.
that answer the
Okay.
question?
Yep, that makes sense now. Yeah.
Great. Thank you for the question. Any other questions before we move on?
Okay, let's move on to the next part. Maybe we can skip over some of the pre-processing of this.
We're running low on time, so we're going to like speed through this. But if you haven't noticed already, we're both big fans of memes. So we're going to revert to this other data set we found on Kaggle, which has memes, and we're going to classify the quality of memes, which is called dank or not. So we'll share this notebook with you. It has this data already from this source. This is kind of what it looks like. You have the author of the original post, the image that goes with it, the title, and the thumbnails and other metadata. So here we're plotting the general shape of the upvotes. So you know how Reddit works. You post, you make a post, and then you get upvotes or downvotes, depending on how the community likes it or not. And we're focusing here on a specific subreddit on Reddit. It's kind of like Stack Overflow. So if you haven't used Reddit, but you must have used Stack Overflow. So yeah. So yeah, this is a common problem that you'll find in the projects. So the way the projects work in this course is you're going to have to find your own data set in most cases, or you might want to find an auxiliary data set that complements the data set that Steve provides. So this is a good example for, and yeah, so down below, we're showing code for how we collected this data, additional data for this memes data set. And what we did basically was we scraped the website. And scraping Reddit is a little tricky because it's sort of dynamically loaded. It's not a static page. So we used a JavaScript test framework called Selenium. I'm not going to go over this code. You can explore it on your own time. But this is going to be useful in your projects when you want to augment your variables to make it more interesting or improve your classification.
So when you scrape data, you most likely won't need Selenium. Just your URL request.get should be enough to fetch the entire web page at once, and then you can process HTML using one of the inbuilt libraries. Usually we go with Beautiful Soup to extract data out of it. Just in case it's dynamically loaded, you need to use Selenium with your web browser.
Any questions? Okay, speeding through. So what we originally did not have in our data set were comments. We just had the information about the original post, who posted it, what was the content, and so on. But if you want to predict, like, if the community liked it or not, if it was a good meme or not, the comments are useful, right? So that's what we scraped in this piece of code, and we've uploaded the merged data set already. This is now what it kind of looks like. It's not in terms of how it's structured. Ideally, these would exist as two separate data frames. But what we're showing you is the merged file. So you have multiple rows against the same Reddit post, but each row has the information about an individual comment. So then you'll see that everything you see on the screen right now has the same values, but if you scroll to the right, you'll see the comments that are different for each row. And as with most real world data sets, it's going to require some pre-processing. I'm going to quickly go over it. So we've individually covered most of what's going on here. Basically, because you have multiple rows for the same post, we're basically picking the unique author, media, title information. So we're sort of aggregating them. And we're not looking at the individual comments. We're just seeing if it was ranked, if it was classified as dank or not, and the number of comments, and these aggregated variables, the number of comments it got, the number of upvotes it got, and so on.
So the reason we're doing a group by ID is that we have multiple rows corresponding to the same post. That's why we want to group it by post ID and then aggregate information across all the comments.
This is similar to how group by works in SQL. So what you're going to get in memes, as it shows below, is a single row for each unique ID, and then you'll get these aggregated columns, which are like basic statistics for how the post did. The other thing we're doing here is just because of how Reddit displays its data, a bit of pre-processing that it requires is the number of total comments had a K in it, which means 1,000. So we're actually converting that from a string variable to a numerical variable by like doing away with the letter K and actually converting it to an integer and then multiplying it with 1,000. So this is now what it looks like. Now we predict how many upvotes it got and if it was good or not. First, let's look at the distribution of our Y variable, the variable that we want to classify, that we want to predict. This is what it looks like. Most of them are actually true, which is surprising.
Can you repeat again how we got this, the Y column?
Okay, so the Y wall column, the way we got it was, this is just, you have to understand how this subreddit works. But just to summarize, there's a bot that is called Savage Axe Bot, and if it posted a comment on that thread saying it's just dank, then we classify it as dank, because that's just how the subreddit works. And so you see a lot of Boolean conditions, and if it says if the length is greater than 0, then that's our Y variable. Set the value of the column dank to either true or false based on these two Boolean conditions. And we're going to use that as our Y variable for our predictions.
So I guess one catch here is that we're using comments as our input variables, and it's also where the output variable is coming from. So make sure that your data set isn't making use of your Y within your X in some way.
Right. So this also speaks to some of the questions that were asked earlier, where you don't want any mixing between your features and your Y variable, right? So if you left this token in our features, I think we remove it down below, right? If we haven't done it here, then that would give away the answer, right? So you want to remove it, you want to pre-process it in a way where your features don't give away the variable that you're trying to predict. Any questions so far? I guess I'm going to speed through even further. Let me run this again. This is again like from the previous data set. It's just showing what are the relationships between the different columns, the numerical columns, in terms of Pearson correlation values. It's always a nice step to do when you're just trying to explore what the data looks like and what you're trying to predict. And these are just again plotting the relationships between two variables using a scatter plot. So you just specify the column that you want on the x-axis, the column you want on the y-axis. This is just saying how to color them. Yeah, because we're using a dictionary here which specifies, for what value, what color we want. And the other parameters are just like visualization parameters for what the figure should look like.
Just a side note here, the correlation heat map is usually it's more helpful when we're trying to do feature selection. So when we build the classifier initially, we don't start with all the available columns in our data set. We start with the one that has the highest correlation with Y. And then we add them in decreasing order of correlation with Y one by one, and then see how much that improves our model.
Any questions? So you can see here, this is the column that we're interested in that we're going to try and predict. The relationship of that column with other columns is fairly weak, I would say. If anything, it's negatively correlated with total comments, which is slightly counterintuitive, but maybe people are much more likely to comment if they hate it. So, they say this is bad, as opposed to, when they like it, in which case, I suppose they only just, upvote it. This is again just looking at the variables that showed high correlations, if at all, between two variables. The difference between this scatter plot and this scatter plot is we're applying a log on the total number of comments. So again, we've moved away from using log in histograms, which is one-dimensional, to using log when you're looking at correlations, because that's just how the variables in real world are distributed. They're often power law distributions, but when you apply log, they look better spread out. And that's a good way to capture the relationships that might be hidden in the raw data. Any questions? So again, we're using logistic regression as before. We're using as our features total number of comments and the total number of upvotes. And the variable we're trying to predict is dank. We split it like 80% for training, 20% for test, as specified by this column. We initialize our classifier, we fit our training data to it, and then we see how well we do. And the results seem to be really good here. So, it says, that you can actually predict using the number of comments in the upvotes if the meme was liked or classified as dank or not.
Although I'd say proceed with caution because the number of observations for these two are quite different. It's 33 versus 143, and the F1 score for false is very bad as compared to for true.
Right. So for the minority class false, because think about it, like if your y variable has such a skew in its distribution, if you just predict everything as the majority variable, the majority value, then you get a high accuracy score just by doing that, and you didn't learn anything. So Charlotte raised like a very important point where you want to keep a close eye on how you're doing on your minority class, which is the value for which you have fewer rows, because that's where you can really see if you're learning anything or not. Any questions? Moving along. So we've used so far numerical variables as our features. Now we're again going to use text as features. We're going to try and predict from the content of the comments if the post was labeled as dank or not. So this should be fairly straightforward to you at this point. Count vectorizer is kind of like hot one encoding. Yeah, I don't think I need to go into that.
Yeah, it's kind of like one hot encoding, except that it does it at a document level. So for example, if the word hello is repeated in a comment twice, then the feature for hello for that particular row would be equal to 2.
So it's just going an extra step where instead of saying ones and zeros, if it exists or not, it's going to count the number of times it exists. And this parameter specifies that, don't include words such as the, these very common stop words. So that's just an extra pre-processing step.
Maybe you can take a look at how X looks like. It's not run, yeah.
That would require running our code. Let's actually try running these code snippets so you can play around with them. This should work. This we run already. Scatter.
NumPy and matplotlib.
So if you want to look at what the count vectorizer does, I guess it's called. So it's a sparse representation. I won't go into. Exactly. It's a little tricky.
So each column here is basically corresponding to one word, and each row is one comment in a data frame. Is it a comment or is it a post? I don't remember.
It's comments.
It's aggregated comments, right?
Right.
We merged all of them together.
Each row is a comment. Each row is a post, and every column corresponds to a word in the comment. So if you want to look at what these columns are, then I think there's a variable of vectorizer.
Yeah.
So this, I think in the order that it appears in this dictionary, right? Correct me if I'm wrong, correspond to the columns that you're seeing below. Does that make sense to everybody? So the number of, let's see what the shape is. We have 500 columns here. This dictionary should also be 500 long. fingers crossed, 500. So every column in the X data structure corresponds to a word here in this vocabulary, and the value in the row count like is the value that it appeared in, the number of times it appeared in.
So this basically means we're using 500 features to predict whether the meme is dank or not, where each feature means the number of times that that word occurred in all the comments on that post aggregated.
Right. Actually, I might have misspoken a little bit. The column corresponding to any individual word is the value of that key for that key. Yeah, and they're here, I think, in an ascending order.
Yeah.
Any questions? I know we're speeding through it a little bit because we're short on time, but we can sort of maybe ask questions on Piazza. We can follow it up. We'll share this code. Take your time with it. Make sure you digest it well, because this is going to be very useful in your assignments and your projects. Moving along. Oh, you want to take this?
It's similar to this.
So we did a decent job. If you look at the scores, we did a better job, I guess. I have to be honest, like especially with the minority class again. Again, I want to emphasize this: the value for which we had fewer rows, we did better on than we did when we were using just the number of comments and the number of upvotes. So when we use the actual text and see what people are actually saying about the post, that's more indicative of how people feel about the post.
Oh, you might want to cover the coefficients part.
So this sort of speaks to a question that was raised earlier, where, okay, you've trained your classifier, but you want to see what did the classifier learn exactly? And so, like I said before, what a classifier does is it learns weights over your features. And so what we're doing here is we're actually looking at which variables, which tokens, which words are most indicative of the variable that we're trying to predict. So you can access the raw weights using coef underscore, and that's what we're doing here. And then you can look at the absolute value because the sign does not matter. And we sort them by the value of the weight. So the higher the weight that the classifier gives it, the more indicative it is. And we're just printing out the 10 most informative words in the comments. The 10 most indicative and the least indicative. Any questions for what this piece of code does? And you can see if people like it, they would explicitly, like words like downvote, they'll post a comment saying downvote if they don't like it. And that's a very important feature. Whereas words like Gucci, guess, other random words, they don't really matter. They don't tell you anything about the variable that we're trying to predict here. So this is actually a good validation for, that our classifier is actually learning something meaningful. It makes sense to us as well when we have a look at the features that it thinks are most important. Any questions? Okay, so we're going to move on from like predicting, if the post was dank or not. We're going to try and predict the number of upvotes it got, and that's different from classification. Classification is when you're trying to predict a categorical variable. When you're trying to predict a numerical variable, that's called regression. So that's what we're going to do now. And you can see that we've switched to linear regression here. Actually, we should have added logistic regression. Is a bit of a misnomer. It's got regression in its name, but it's actually doing classification. There's a long story behind it. But again, the takeaway is when you're trying to predict a categorical variable, that's a classifier. And logistic regression, despite its name, is a classifier. And here we're going to try and predict a numerical variable. And this problem is called regression. And it's actually related to how Pearson coefficients are computed as well. But yeah, so it kind of just applies a linear fit to the variable that you're trying to predict, which in this case is the number of upvotes. Any questions on the difference between classification and regression? Okay.
So similar to how we were using precision and recall in classification, here the metrics that we usually go for are mean absolute error, mean squared error, and root mean squared error. So what each of these mean are, when you look at the absolute error, it's basically telling you how far away the y coordinate of the test points was from the value that you predicted, and average over all the points in your test set. The mean squared error is, I think, just the mean of the squared absolute error.
Right.
And the RMSE should be in a range similar to mean absolute error. Instead of simply adding up all the y values and taking an average, we're averaging the squares and then taking the square root.
And again, I think Steve would cover these variables in detail in the class. But you should know how to use them and how to get them out from a classifier in Python.
So I think that the only difference between these two here is that here we're trying to predict the number of upvotes from the total comments directly. Instead of that, if we try to predict the log of the y from using the log of x, it's the graph looks slightly different. So this is what we meant when we talked about cross-validation. So instead of just running it once, we're basically looping it across 10 different iterations, and we're specifying a different random state every time. And the graph that you see here is the mean squared error plotted across multiple iterations, and then the value that you usually report in the end is the average across all of these.
And you can see there's high variance in our scores. So, you might want to be a little careful for what you report, because in some cases it does great. The accuracy, the error is like down to 0.2, but in other cases it's up to 0.9. So that's also an interesting statistic to report, just for transparency, that this is our mean score and this is the variance of the score.
So far we were just using one column. I think we were just trying to predict the number of upvotes using the total number of comments. But in most cases, you will use more than one column at a time for your regression task. So we call that polynomial regression, where you have more than one input column. And in this case, the way that we're demonstrating it is, instead of using simply the total comments, we're taking powers of total comments as our input. So the way we've done that is we've simply applied this function, the lambda function here, that raises to the ith power. And then we have this filter data frame that is basically x squared, x cubed, and so on, up to, I think we've gone up to 20. You might not, this won't probably be a very common use case where you square all your columns up to 20, but you might need to take the squared of perhaps one or two of the variables, where I think I remember doing it in a house data set where there was a length and breadth column and we wanted to use area instead, so we ended up squaring the columns. So what this function is doing is, does it do normalization, or do we have to do it separately?
I think so. Maybe you can scroll up and see what the scalar, how it was initialized. So again, we're doing some kind of pre-processing. I think the standard scalar, if I'm not wrong, the way it works is it just ensures that your features or whatever the column you specify is between a certain range. And in this case, because it's standard, I think it's 0 and 1. So that's what's going on in this fit transform, scalar.fit transform line.
And then the code following this is similar to what we did for classification. We're basically fitting it on the training data using total comments. While predicting, we're doing it on So what this is showing us is the fit for two different kinds of regression, one where we were using linear. So the line for linear is the only input feature is the number of comments. And the line for polynomial, as you can see, it's highly overfitting the data. It's where we use all the powers of x up to 20. So this is a scenario that you'd want to avoid. You want to avoid overfitting on the training data. And we have two inbuilt modules for that as well. So there are two variants of regression called ridge and lasso. You'll cover this more in lectures later. So they basically prevent it from overfitting on the training data. So if you can see this additional blue line, that's not exactly similar to linear. It tries to fit the data slightly well, but it doesn't go overboard and try to fit the training data as closely as possible. So what Ridge does is basically it limits the coefficients for each feature. And what Lasso does is it tries to do feature selection on its own, where it forces some of the coefficients for the features to be set to 0. So in this case, Lasso isn't using all the 20 features that we specified. It's forcing some of them to be 0. So it's still better than a better fit than linear, but it still isn't overfitting. And there are parameters to both of these that you can specify as well. Yes, we're at the last part. So this is a different task altogether. Here, we don't have a Y column that we're trying to predict. We simply have our observations and we're just trying to see if they somehow cluster together naturally in their own way. So k-means is the most commonly used variant of clustering, also available as a library module. So what it tries to do is basically group it into the number of clusters that we specify. Here we're specifying it as 5. And we're coloring each cluster using its own color. And when you plot the data, you can basically see whether they naturally fall into different groups. So in this case, although we're specifying 5, I don't think they naturally fall into 5 groups. I'd say probably 3 would be a better number to cluster into. Any questions about clustering?
So clustering falls under this this class of algorithms that are called unsupervised algorithms, unsupervised techniques in machine learning, where it's not expecting any variable that you're trying to predict. It's just trying to learn patterns within the features, within the columns you're specifying. And so it sort of puts together where the rows that are similar in terms of their features. And you can this is a common way to sort of create your own variables, where you want to say, like you said, for instance, with the old data set, how would we sort of clump together different professions into a broad category? So clustering would be the way to do it. If you want to, so ideally you would expect writers and painters to be closer to each other than writers and, say, construction workers. Any questions on clustering and unsupervised learning?
I think we have a few minutes to spare. Do you want to?
So just to sort of reiterate, like one major takeaway that you should have in mind is notice how much time we spent on pre-processing our data set. The actual applying a classifier, fitting it to your data, that's just a small chunk of the code. That's a small part of your intellectual, would take less of your intellectual time as well. Most of the effort goes into actually understanding what's in your data and getting it into a form where then you can use classification effectively. And that is something that you're going to have to go through in your assignments and your projects as well. And I think we sort of really sped through overfitting as well, so maybe you can spend some time on that. Overfitting is essentially, kind of like cramming, where and then there is this trade-off between flexibility and generalizability. The more parameters you allow your model to have, the more it's going to give it flexibility, but then there's always this fear that it's going to really just learn something that is unique to the test set or the training set that you specify, and it's not going to generalize to new data sets or the test set. So that's also something to keep in mind.
So like you can see with the polynomial line here, it's very unlikely that a new unseen point will fall exactly on this line. So in this case, the linear would be a better predictor in some sense of unseen data.
Any questions?
Do you want to talk about scraping?
For those joining us remotely, any questions? I guess I'll also add that in our case, in this data set, it's particularly important to not overfit, because you saw how, depending on their train and test split, the scores changed like so much, right? Depending on how you cut up your data into 20 and 80% you can either get a really good score or you can get a really bad score. So in those cases, again, it means that the data is messy and you don't want to like use a model with too many parameters, because you might get a good score for the training set, but it would not generalize well to the test set.
We also skipped through scraping a little bit. So if you're not familiar with how to use these libraries, it basically lets you, Beautiful Soup is this library that lets you find elements in your HTML page using the tag name, and you can also specify the attributes that you want to find. So this find all function is basically returning all the comments on the page for the URL for a particular post.
So, you know, HTML is a markup language, kind of like XML. So you want to look for specific tags within that HTML page. And that's what we're doing here. And then we're within those tags, we're extracting the specific attributes that we're interested in. Also, scrape websites at your own expense. In some cases, it might be illegal. So yeah, we're not responsible for any violations of law.
Yeah,
But
the way you would write that code for scraping is basically you go to the element that you're interested in on the web page, and you can find all of its details in the inspect elements browser window. So if I was interested in scraping what the contents of this particular part of the page are, I would simply click on inspect and go here and check out what the properties for this tag are. So in Beautiful Soup, I could specify extract all the elements which have ID equal to top menu bar.
Any questions? How many of you have done scraping before? Oh, it's quite a large number. And so we're using, and just to reiterate, we're using Selenium here because this is not a static page. When you call the page, it does, all the content does not load. It takes a while. This is why we're using a test framework, Selenium, where we're waiting for the content to load and then dynamically getting the attributes that we're interested in.
So I think you might not be able to run this on Colab directly,
Right.
because you need your Selenium browser driver.
Yeah, and I think Tanzir told us before the lecture that in regard to the previous lecture, there were some comments about the general Colab environment, the general Jupyter Notebook environment. So if you have any questions there, we'll be happy to answer them. Yeah.
Do we have to mount a drive every time we need to
I think so for Colab, but ideally for your assignments and your projects, I would recommend installing Anaconda and using Jupyter Notebooks on your local laptop. Colab is nice and shareable, so you don't need to set it up, the libraries and the Anaconda, to just start to play around with this. This is why we're using it. But for your assignments and projects, I would recommend using Jupyter Notebooks that come with Anaconda. Just Google Anaconda, you'll have to download the whole bundle, and then you can set it up and start a Jupyter Notebook server and run it locally.
Yep. Anaconda is especially useful for maintaining environments where if you have different dependencies, you get to install it specific to that environment, so there's no dependency clash between the two.
And that way you'll be building on your local file system, so there's no mounting or anything, because it's all being done locally. You don't even need to have an internet connection to run Jupyter Notebooks on your laptop. Any other questions? How are we doing on time?
3 or 4 minutes.
Okay.
Anything else that you want us to go over again in more detail?
What is the difference between that min max scalar and the robust scalar?
So the question is, what's the difference between the min-max scalar and the standard scalar?
Yeah, standard or the robust scalar.
Robust scalar.
I haven't heard of robust.
Yeah, I haven't heard of robust scalar, but maybe you can talk about the min-max scalar.
So I think what standard scalar does is it does x minus the mean, x minus the deviation divided by the mean.
Right.
And what min-max does is x minus minimum divided by maximum minus minimum. So it's basically different ways of converting values to a standard range. Let's look at the docs. So sorry, it's x minus mean divided by the deviation.
So I think that again, the standard scalar, and when you apply it to any column, the transformed column is going to have mean equals 0 and standard deviation equals 1. And the min-max scalar is, I think, just going to make sure that your values, the extremities specifically, are at 0 and 1. So the minimum value within that column is going to have the value 0, and the maximum value in the column before the transformation is now going to be 1. And it doesn't say anything about what the distribution within is going to look like. In fact, the distributions stay preserved. It's just like shifting it onto the number line is one way to put it.
So the min max scalar, they make sure that the values will be between 0 and 1 after the transformation.
Right. So the minimum value that was before the transformation is now going to be 0, because previously it could have been negative million, right?
Correct.
Now it's
Correct,
going to be 0, and the max is going to be 1.
So the standard scalar doesn't take care of that part. That minimum will be 0. It doesn't like make sure that the value will be within this range.
No, the standard scalar, yeah, make sure that the mean is 0 and the standard deviation is 1.
So you might want to be a bit careful when you use min-max scalar, especially if you're dealing with logs. So you wouldn't want to scale it to min-max and then take a log, because that would result in log of 0.
Okay, yeah. Thank you.
In most cases, you would find yourself using the standard scalar because you don't really care about the min-max values in most cases, because those are outliers anyways. And so you might want to just focus on the major chunk of the distribution, which is generally around the mean.
And the standard scalar is actually an important step in normalizing your data, because if one feature has a range from, let's say, -100 to +100, and the other one is just -2 to +2, there's going to be a large difference in the coefficients when you run your regression model on it. So it's important to bring all the features down to the same scale.
Any questions? I guess we don't have any questions. We can wrap up.
We're out of time too.
Yeah. Okay, we're going to end here. If you have any questions, you can post them on Piazza or send us an email as well. You can contact Tanzir as well, and we'll be happy to respond.
We'll be sharing the notebook again after this class
Yeah.
as well.